Alright, so in this one here, this video today, we're just gonna do a win condition so we can move on to another room. We're gonna make our spikes move so that they are actually hazardous instead of just being on the walls. We'll probably do something with tiles as well, and possibly if we get time for it, we will put some coins in there so there's a bit of a score. Let's see. So you can see I drew flags here. This is just a sprite for the win condition. You can put a trophy or whatever you want. This is an object that we will be colliding with to to move on to the next room. So this is such a specific object, and there's only going to be one instance of them. In this case, it's okay to put code in here. We didn't do that with the spike for the collision for hazards because figure there might be more than one hazard. It might not just be spikes. So we'd rather check for that in the player movement as we did. But since there's only one of these objects in a room, typically, we can put code in here. So let's do that. Put it in the step. And actually, let's use an alarm. We haven't used one yet. So first thing you do with an alarm is you instantiate it. So alarm 0 equals 2. We want to save some time with this so it's not bogging down the memory usage. We're only going to run this every other frame. That's what setting it to 2 kind of does. If we set it to 1, it would function just like a step because it would execute every 1 frame because you're only pausing 1. In this case, we're pausing for 2 frames. So let's do the collision test here. So collision rectangle. In this case, it's a very simple one. And with the object player in this case, we're looking for the player. Precise, doesn't need to be, not me, nope. So 0, 0. If it's not equal to no one, if there's a player there, that's our, let's comment this a little bit. Player collides with us. So in this case, we are going to want to play a sound. So we'll play SMD victory, and that doesn't exist yet, but we will play that. We'll put one in. And we'll set another alarm there. Alarm 1 equals, let's do 20. So this is going to put a little bit of a delay between room switches. And if we don't collide, we'll keep looking for the player. But yeah, this alarm here will put a 20 frame, which is approximately equivalent to a third of a second. It'll put that between room switches. We'll put it a little more. Let's put it at 2/3 of a second. Make it a little bit longer so we can listen to the sound. We can see that he collided, and then it'll move. But we do need a sound since we said we would have one. I'm going to put SFXer up here. Let's see if I can boot that. This is our trusty tool. This is a great tool, like I've mentioned before, for making waves on the fly. Sounds okay. Sounds even better. That's good. Now you can even change things here. I don't really mess with these because I'm not a sound guy. I'm a programmer, but if you're into sound and you want to learn how to modulate these a little bit more, you can do that. Let's see if we can do a little longer. Make it last longer. That's kind of what we want. So export that. When I'm just being lazy putting these in the back or in the desktop, but you could have these go directly into a game folder, whatever you want. And I forgot what we named it already. Isn't that crazy? SND victory. So okay. SND victory. Bang. So that'll work out pretty well. And we need to pick what alarm 1 is going to do. So alarm 1 does this. How about we'll set, and this is how you access other objects variables. So you set the, or you declare the object right here, so object control. And this will affect all the objects with that, all the instances of this object in the room. So in this case, we only have one, so we can do this with ease. But if you have multiple instances, you want to be careful when you're doing this. It will affect all of them. So let's set, we're going to make a custom variable called next, and we'll set that equal to 1. Alright, so here we need to set that to 0 though. We need to set this variable. Next equals 0. And what are we going to do? We're going to do this right here. If next equals 1, and remember how we did the def condition? We're just going to do that right here, except we're going to make it a little more cheerful. Room completed. Press R to proceed, why not? So, that looks great. And you know what, since we did do the death condition in the player, we might as well do it here too. Okay, you know what, we're going to leave this right here. Just because this is starting to get, you can see, a little bit bloated. We're going to leave that. We'll put one right here. Alright. Next equals 1. Room go to next. Okay. We don't have another room yet, but we will create one. Just duplicate that for now. I know, no big deal. And we do want to place this win here, so we want to allow them to win. Put it right there. And I'm going to clear these out because we're going to work with the spike that moves in a little bit. So for now, though, we just want to make sure you can win. At least win that room, not win the game yet. Not quite yet. Alright, let's see. Cool, our lives are working. Good. That worked out quite well. That's a little off screen, we'll fix that. And you know how, you see how I'm keeping the menus sort of consistent? They're all in control. That's what you want. You don't want multiple things happening in different objects that are supposed to be in the same category. So it's kind of categorizing the events here. Room completed. So we're going to move this in a little bit. And I'm going to move it up. And, you know, those values, like I said, they're kind of arbitrary. As long as it looks good, that's fine. I like to use the room width and height. This way, if I scale it, I don't have to worry about specific magic numbers floating around in there. It still looks good even if I scale. That looks even better. Look at that. And it does proceed. You can see we don't have the object here, so it is working. That is perfect. Alright, so we have flags. We want a spike that moves, so how much do we want it to move? Well, let's say the equivalent of about 3 spaces, and each is 32, so that's going to be 96, I believe. Let's do this. Set movement direction. There is a default variable called direction, but since we're not going to use it, we're going to use our own movement system, so I don't want to screw with that too much. And we'll keep it clean, actually. We're going to put an underscore here so I can tell what's going on. Move direction equals 0. And we're going to use alarms again, so it's a good thing we have already used them a little bit. Alarm 0 equals 20. Alarm 0. Move direction equals, well, we're going to use a 1 and -1 system for this. You'll see why. And we're actually going to set, actually, yeah, that's fine. So this one is going to, or this object is going to start off moving to the right, since it's 1. That is typically an increment of 1. Step. Collision rectangle. Actually, in this case, let's do a collision line, because it's just moving in a line. Yeah, I mean, B-box top is fine. Yep. Or in this case, we'll use Y. That'll be the center. X left, Y here. B-box right. And here we'll use Y. Object wall. Precise, no, not me, no. And we are going to duplicate this because we want something that sets our movement direction negative, right? So, I mean, that's a simple way of doing it. There's other ways to do it, sure. But for now, this will work. Set it to 0. Set alarm 1 equal to, so if it hits the wall, we want it to stop for a little while. This is how long it's going to be stopped for. Let's do 45 seconds, or 45 frames, 3/4 of a second. Okay, so if there's depth there, if it hits that, it's going to stop moving. We do want to take into account the move direction. And in this case, we're actually going to multiply it by a value so it moves at a certain speed, you know. Move direction is just there to change the sign, essentially, since it's going to stay 1 and it's going to go positive or negative, essentially. That's all it's doing. So yeah, you set it to 0. And then in this case, if it's 0, it won't matter at all. It won't be doing this. So we're going to also check if move direction is not equal to 0, because we don't want to check for a collision if it's not moving. Else, we're going to move. So, and we're only moving along the x-axis. Times 3, that is the, essentially if this was a vector, move direction would be the direction or angle, and this would be the force applied. If you can think of it like that, if you, people might know. And now all the spikes are moving, which is not what we wanted, but that's fine. So we're going to get rid of some of these, since all of our spikes move. Essentially, I mean, there's no point in having a stationary spike if you do think about it, because, right, what's going to happen? You're not going to run into it on purpose. I'm just going to check over this again. So, move direction equals 1. Perfect. Direction equals -1. Again, that's good. Okay, move direction equals 0. Alarm 1. So, here's the problem. This assumes that move direction was already 1, because we're setting alarm 1 instead of setting alarm 0. You know what I'm saying? There's 2 different ways you could move. Let's do it like this. Let's do... We're going to use one alarm. And now we're just going to toggle it. This will just multiply it by -1. So if it is negative, it turns it positive. If it's positive, it turns it negative. But now we don't have, we can't put it at 0 because then it will never get turned to 1 or -1. Because if you're multiplying 0 by any number, it stays 0. So we're going to set it to 1. And we're not going to even put that there. So it's going to start moving right. We have to keep that in mind. Now, we don't need that. We're going to use, instead of using move direction equals 0, we're going to use the alarm. So if alarm 0 equals -1, that means if alarm 0 is not timed, if it's not right now being set, and we want to check to see if it is set. So if it's not being set and we collide, we want to set the alarm, and that's going to prevent us from moving, hopefully. So, or if it is, yeah, we want to use that. So if it is set, and you collide, let's just give it a try. Confusing myself here. Yeah, I'm doing this all on the fly, so let's make sure. Okay, that's bad there. If collision 1, perfect. Alarm. If alarm 0 not equal to -1, or is equal to -1. If alarm 0 is not set, we can move. Perfect. Sorry about the confusion there. Like I said, I'm doing this all on the fly, so I have to kind of think of it as I go. This is kind of the most fun part of making your game, though. Programming traps and things like that. As you can see, that one did not stop because there was nowhere for it to stop, but this one did. And it is not moving back, which is what we wanted it to do, so that is a problem. We're going to put a wall right there. That's perfect. And you might notice we don't have anything for the player going off screen, so that could be a feature in your game, though. You know, if you go too far to the left, maybe it just puts you at the right, like a cartoon. Maybe you can wrap around the screen in that way, or maybe we just stop him. We're probably going to stop him, but we'll worry about that in a second. Let's make sure these spikes work. Okay, perfect. Alright, if collision 1, alarm 0 equals 45. Okay. We want to make sure alarm 0 is equal to -1 in this case. Because otherwise, if we're still colliding, we're going to be setting alarm 0 over and over to 45. That's the problem we're running into right now. It keeps getting reset, and then it's never going to time out and count down to what we need it. As you can see, it's working quite well now. Just needed a little tuning is all. It's not bad. See if we can even get hit by this. It's a little easy. Again, your maze doesn't have to be the hardest. Perfect. If you wanted to make that harder, oof, we got a lot of spikes there. If you wanted to make that harder, you could just set that time to a lower value. And that'll make it plenty harder. Let's try that out. I like having fun with this. That's the point of making games, is to have fun, right? So test it as much as you want. Make something you enjoy. Perfect. That's pretty hard to avoid, I would say. Okay. Good. Like I said, we did have a problem with the player going off screen. So function move, let's take care of it there. This is our movement handler. Else if x plus argument 1 less than room width and is greater than 0. Keeps us in the room right here. That's all we're doing here. And we're going to use multiple brackets, or parentheses in this case. This is just keeping track. So keep track of your brackets. Make sure they are appropriate, or that rather that they work. Y plus argument 2. A little confused here. And y plus argument 2 is greater than 0. Well, that's perfect. Looks good to me. Now let's add a coin. I haven't drawn this in the beginning, but I'll show you a sprite editor. Haven't done that yet. We don't need precise collision checking. No, sir. Do a 32 by 32 here. Actually, you know what? Let's make these a little bit smaller. These are coins, so okay. That's a good looking coin right there. Let's give it some shading. I like the shade. You don't have to, but it does make it look kind of nice. Oh. I'm gonna go back over this, make it a little lighter. Okay, that's pretty good. And then we'll give it some sort of arbitrary cent value, you know. We're gonna want to do that, and then bang. Looks good right there. I like that. Perfect. And you know, things that you want to get usually in your game, you want to make them a little bit flashy. So make them kind of shine, I guess, if you want to call it that. Keep that there. Let's go up with that. It's gonna sort of blink. It's a little subtle for us. Let's do a little bit more than that. Image intensity. It's perfect. A lot of objects open here. You know what? I should get rid of this for good. We're making an object coin. The first thing we're going to do is set the speed, because you just saw it was flashing pretty dang fast. Image speed indicates how fast it's moving, and it's from 0 to 1 actually. It's not any other number. That's all it goes from. 0 means it's not going to move at all. 1 means it's going to move at its default animation, which is 1 frame per frame of the game. We want a half frame movement per game, so that actually let's do a quarter. It'll move every 4 frames. It'll move to its next frame, and the animation does loop by default, so we don't have to worry about taking care of that. And again, let's do an every other frame collision test, just like we're doing with the finish line, because this isn't something that needs to be frame perfect. This player is going to sit there. He's not going to run into it and run past it. Even if he does, it'll be more than 1 frame. If collision rectangle should be used to this by now. We're just going to instance destroy. So, and there's something neat we can do here. If we put that there, we can actually go into the destroy event and handle all of our sound and everything in here. You know, our score increment. There is a default variable called score. We'll increment that. No, let's make it 10. It doesn't matter. It can be anything we want. We can have nickels in there, dimes, whatever. Sound play. S&D coin. I don't have that yet. Let's make one. My SFXer's coming back up. I should just keep this thing open. I use it so much. I love this tool. It's just perfect. That's pretty good. That's pretty good. I'm gonna make it a little long. It's the punch. Yeah. Works. I don't mind. The reason I'm not making all these resources, you know, instantly available to you is because I want you guys to make your own. It's more fun that way. Don't just copy everything everybody else does. Here I'm showing another way to put your sound in. I've done it other ways, but that's fine. Load it in. But yeah, as I was saying, you should be making your own resources in these sorts of tutorials. It's no fun if somebody hands you everything and they hand you the code and you just build it like a robot. You should be building it your own way. But yeah, the code, definitely follow along if you need to. So yeah, we're playing S&D coin. Let's put some coins in the room. And we have snap to grid. We could always turn that off, but I kind of like it. About 2 coins there. We could put some right there too. And you know, I am going to make a stationary spike. This way I can show you guys. How inheritance works. So its parent is object spike, but we're not actually going to borrow too much from it. Move direction you can keep. We can delete all of this actually. Delete all of this. Oh, here, how about this? Since it's going to inherit the events from the other object, we do in this case want to keep the step event because we don't want to borrow the other object's step event, and it will do that. So we are going to just put, let's just do this. I don't know if I spelled that wrong. That's fine. I don't want to inherit, because inheritance does work that way. It will automatically move in the moving spike step event, and we just want it to be not moving. So it is stationary. Bang. Yeah, we could have multiple spikes with different. You know, one could be facing the other way or facing left or right. It's just, you know, a technicality. It's pretty easy to do. You guys could figure that out. So we've got that there. Perfect. And check hazard will still work because we're checking for object spike, and this is still considered a spike because its parent is a spike. It's a spike, but it's a stationary spike. That's essentially what that's saying. And depending on, oh, this is a long video already. Otherwise, I was going to draw sort of a parent tree, but won't worry about that. That's beautiful. See if we can get them all. Nice. Bang. Good stuff, guys. Alright, so that's it for today. In the next video, we'll kind of wrap it up. We'll probably put in another room, maybe put in a key to get through walls and barriers, and that's about it. Alright, thanks for watching, guys.